So in the next few minutes, we'll be talking about a duo that's been making waves in the Python web development community, GraphQL and FastAPI. So GraphQL is an API specification created by Meta, and FastAPI is a web framework for creating efficient and lightning-fast API. And FastAPI is recognized for its fast simplicity and asynchronous support in Python. We'll be talking about these in the coming talk. Yes, about us. So I'm Aby M Joseph, and I have Thameem with me. We are product engineers at UST Stolby. At Stolby, we are building a travel platform, and we have been working on GraphQL microservices in Python for quite a while now. And we are also part of Trivandrum Python community, which is based out of Kerala in India. Yes, that's all about us. Let's move on to GraphQL. So what is GraphQL? You query your database, you could query your API. So that's GraphQL for you. And it's designed to make your APIs smarter and reduce the overhead of data communication. So as a backend developer, GraphQL provides a type system where you can describe a schema for your data and in which in turn gives the front-end consumers of the API the power to explore and request the exact data what they need. Yes, that's about GraphQL. And let's look what's the difference between REST API and GraphQL. So traditionally, front-end developers have consumed APIs using REST, where data entities live on a bunch of URLs on the server side. So when a request is received, the API responds with the full data payload of that entity. That sounds simple. That's the REST API. But there are major potential drawbacks for it. We might need multiple entities at a time, in which case the each request is underfetching what the actual data we want. And in other case, we may only require a small subset of data entity in which we need to overfetch from the API, and that, of course, is affecting the efficiency. And talking about more cons, so different clients will have different design requirements, and which makes us to make it difficult to manage REST APIs and managing different versions. So as APIs evolve, maintaining different versions to support backward compatibility can become complex. And excessive use of data transfer due to overfetching and numerous API calls for a single page, which is nothing but over underfetching. And for example, if there are many clients, mobile client, web client, and desktop client. So sometimes mobile design requires only the name, while the other clients like web and desktop require name, address, and all these things, leading to inefficient data flow. Using some API for same API for all clients will lead to underfetching, overfetching of data in case of mobile client. So coming to the core concepts of GraphQL. So GraphQL provides a schema for the data and gives client the power to ask for exactly what they need. And it sits between the client and the backend server. So in practice, GraphQL and REST both send HTTP requests and receives HTTP response. But GraphQL centers around the resources and URLs, while GraphQL provides more control over the data access. And here we are focusing on four things: the schema, query or mutation, or the requests, and the server side is resolver. So think of schema as a blueprint for your APIs. So in GraphQL, the schema is your type system. It's where you define every piece of data your application could work with. It outlines the structure and the relationship between various data entities, almost like a contract between the server and the client. So you are saying in the schema, here are the objects and here are the fields for all those objects, and how they are connected or how they are related. So this clarity is what makes GraphQL so powerful and developer friendly. And it also allows us to create custom types like scalar, and we can create object types using complex object types, or using a combination of scalar and object types. And here, the client can fetch the schema initially and use the queries and mutations in the schema, and use the types defined there in the schema. And using that, we can make the client can make requests to the service and fetch the response based on the request. So here, the request can be query or mutation or even subscription. So now, so query is used to retrieve the data from this server. So it specifies what type of data you want to retrieve from the fields of which type. It is similar to the GET request in REST APIs, but it also allows exactly specify the data you need. It's will definitely reduce overfetching and underfetching issues in REST. And also, we can also request make mutation requests, which can modify the data on the server. It can be used for creating, updating, or deleting data. So mutations are similar to post, put, or delete operations in REST API. And at the end, the resolvers in the server side. So we have resolvers in the server side, which are the behind the scene functions that return the requested data. So they are the bridge between the GraphQL server and the database, which ensures that every query or mutation translates into the right operations. So the operations allowed in GraphQL are queries and mutations. So query is like the entry point for read operations. They allow the clients to specify what the data is required, making the queries efficient. Unlike REST, we can specify the shape and the size of the response which we need. And the queries empowers the client to detect the structure. And this precision eliminates the overfetching and underfetching of the APIs, leading to optimized network usage. Also, there are mutations to change the server-side data. So in GraphQL, it provides a clear and structured way to perform mutation operations. Like queries, we can also specify the structure of response, enabling to get immediate feedback. So another operation supported in GraphQL is subscriptions. Subscriptions provide a mechanism for real-time data updates, allowing clients to maintain a constant connection between the server. So whenever a specified event occurs, data change, it might be a data change due to a mutation, the client pushes the updates to the all subscribed clients. So by leveraging these operations, we can build more and more efficient applications. So this is a classic example of GraphQL versus REST. We use it for understanding the concept. So REST is like ordering a burger in a restaurant with a fixed menu. So there is no predefined option. There is a predefined option, and there is no option to custom made the burger. We have to take it full, or you don't. You can cancel it. Or in the case of GraphQL, it's like ordering. You're going to a restaurant with build your own burger concept. So you can specify whatever you need. You can specify where we need lettuce, cheese, or something like that. So that's what GraphQL gives the flexibility. Here, the waiter in the restaurant is like the schema. So he has, or he or she has the clear list of available toppings or the ingredients, and the chef act as the server resolvers. She knows how precisely to make the based on the custom order. So this is a classic example of REST versus GraphQL. And we can integrate GraphQL concepts to Python using some libraries, especially for schema generation. So there are two types, code first and schema first. The code first we will write the code for the schema first, and after executing, we will build the schema. So example for code first approach are graphene and strawberry, and example for schema first, where we put the schema definition language, and we'll generate based on that. That's Aridani. So then over to Thameem for FastAPI concepts.
So good morning, Seattle. I hope I'm audible. Now we can discuss a few things about FastAPI. So in today's world, APIs are the backbone of modern applications. They power everything from mobile apps to complex web services. But when building APIs, performance is key. Users expect lightning fast responses, and slow APIs can lead to frustrations and a very bad user experience. This is where FastAPI enters the scene. FastAPI is a high-performance web framework for Python that allows you to build blazing fast APIs. So FastAPI isn't just about speed. It also builds on solid foundations. It leverages Starlight, a powerful ASGI framework, ensuring your APIs are robust and reliable. It also integrates seamlessly with Python typefaces. This means your code is not only more readable, but also less prone to errors. Typefaces act as a documentation within your code, making it easier for you and your team to understand the expected data and functionality. For this, FastAPI use the popular library called PyDynamic. So, Abby, can you just, yeah, this is the overview of FastAPI, the architecture of FastAPI. So now, beyond the basics of FastAPI, it offers a whole host of features to streamline your development process. So these are the few things. Yeah. So apart from the speed and the developer-friendly nature, FastAPI utilizes open standards. It's built upon OpenAPI, formerly Swagger. I hope you all hear about the OpenAPI standards and the JSON schema. This means your API automatically generates interactive documentations really understood by developers using popular tools like Swagger AI. This not only simplifies the integration, but also promotes the collaboration within the team, or like the collaborative nature, the interconnect with all the cross-functionality teams, like that. So, and also the automatic documentation will save hours of writing the detailed API documentation. And another feature is data validation, as I mentioned earlier. The validation is critical for robust APIs, right? So FastAPIs empowers you to define data models and enforces strict validation in incoming requests and the responses. This ensures your API receives data in the correct format, preventing errors and potential security vulnerabilities. So the next one is path operation. It's like FastAPI provides a granular control over how your API interacts with different paths. So like we may have admin, we may have user, we may have dashboard, or like that. So it's defined various path operations like get, post, put, and delete, allowing for a specific actions on your API resources. This fine-grained approach ensures your API creates to multiple use cases. So, and yeah, in case of security, FastAPI offers built-in support for authentication and authorization as well. You can easily implement features like auth2 or JWT to secure your API endpoints and protect the sensitive data. And also, FastAPI promotes the concept of dependency injection. I hope you all are aware of about the dependency injection. This means you can decouple your code from concrete implementations, making it cleaner, more reusable, and easier to test. For example, imagine needing a database connection throughout your API. With the dependency injection, you can define a dependency for the database connection and have FastAPI automatically inject it whenever needed. So like an API A have a required database connection and B may not. So we can use the dependency injection feature here. Yeah. So now talking about middlewares, it acts like a mini application that intercept the request and response point to your API. This powerful feature allows you to extend FastAPI's functionality in various ways. For example, you could create a middleware to log your API request and responses, handle the authentication across your API, or maybe like adding rate limiting to prevent abuse. Yeah. So finally, the asynchronous power. The modern world demands efficient use of resources, right? So FastAPI's asynchronous support allows us to handle multiple requests concurrently. That's a main feature. This improves the scalability of our API, our application, making it capable of handling high volume of data, uh, high volume of traffic without compromising the performance or cost or something like that. So yeah, so now we have discussed about FastAPI, GraphQL basics. So now we can develop a simple GraphQL API using the FastAPI framework. As you can see in the code snippet, I have added a route or path called GraphQL. You can see that. And I can simply access the same using the endpoint base URL slash GraphQL as we run any other applications. So here the application is running on the localhost and the port is 8000. So I can access the same by localhost colon 8000 slash GraphQL. So now we need, now the objective is to define a query called post, which simply returns the details of a given post by an ID. As mentioned earlier in the presentation by Aby, for developing a query, mutation or subscription, we need to write the schema. So I have utilized Graphene for the same. So we have multiple ways, right? Graphene, Strawberry, and so on. So here I have used Graphene. So yep. Yeah, here you can see that we have post type, query, and GraphQL schema. In the post type, we have defined individual fields, ID, title, and summary. Also, in the query type, we have defined the post or query and its solver to return the data. And in each resolver, we need to write the business logic. When need to skip something or like that, the business logic comes inside the resolver. So also, you can see that the query and post type are inheriting the Graphene object type. And now we can build the schema using Graphene and then pass the same into the GraphQL route defined earlier. For handling the request in the route, we are using styled Graphene. So now, here in the given screenshot, you can see that I have called the query post and it simply returned the sample response details. Now, the another feature is GraphQL federation. It's nothing but building a single API endpoint for consumers while giving the backend developers the freedom of building independent, self-contained services, or like exposing the GraphQL schema into a single endpoint by combining multiple subgraphs, which can be utilized by the front-end clients. As you can see in the diagram, we have three services: service A, B, C, which have its own GraphQL schema. By using a gateway, we can combine these three GraphQL schema into a single point, and the consumers can utilize the same. Here you have iOS, Android, and the web consumers, so they can utilize a single endpoint. So we can just Another point about the GraphQL federation is we can combine data from multiple services and return into a single mutation of query. For example, as shown in the diagram, the post query will return the type post type. It contains reviews, the title, ID, and the other details. Here you can see that clearly the other details is returned from the user service, and the review is returned from review service, and the basic details about post, the ID, the title are returned from the post service. So maybe these three areas are owned by three separate engineering teams. They are responsible for building these areas, these domains, and maintaining the system. So Now, in an unfederated implementation, we have this simple schema owned by individual teams. In federated architecture, we will extend this type. Like here, we will extend the review type and the other type into the post. So we can leverage this feature of GraphQL, federating or extending types between types across the services. So that's about GraphQL federation. So here is a symbol. We can just move to the previous slide. Yeah, it's a sample query which will request for user information, and inside that there's all details about the post written by this user, the current user. So here the user is a user. The user data is returned from the user service, and the details about the blogs or articles is returned by the post service. So this is the example for GraphQL federation. Yeah. So I think that's all from my side. Aby, yeah, can you just move to the demo?
Okay, as we are limited time, I'll start with where Thameem ended. So we have two microservices here. User microservice, which has a schema with the user type, and a post microservices. We'll be running it. I'll share this code in the channel. So just for sake of understanding, I'll Okay, Harvard, and we have a post microservice with a post type. So as we need to federate, so as we, for a sake of example, we need a distant requirement is there to list the user data along with the post they did or they posted in the previous days. So for that, we have to federate both GraphQL and post, so both user GraphQL type and post GraphQL type. So for that, we have to build a unified schema. So for that, we are now using Apollo GraphQL. So where we can use federation with multiple subgraphs. So we have shared the routes for both the subgraphs, user microservice and post microservice. And upon running the script rover dev supergraph command, we'll federate the supergraph. Let's see that. Yes, the supergraph is generated. So a single graph of post user microservice is like here. We can see the Explorer, like we have 5 fields for, or even 6 fields for user service. But in the federated one, the user type is having the next field, that's post, which resolves all the posts created by the user. So for that, uh, we have a custom type user, which is extending in post microservice, and of which the email field is a key which is external from the user microservice, and we'll be resolving all the posts created by that user based on the email. So that's a simple example of GraphQL federation. So as we are limited time, we'll stop the demo here and we'll conclude by the session. So let's, as we wrap up this talk, let's take a moment to go back to what we have discussed now. The speed of GraphQL and the fast API coupled with the flexibility makes this combination an attractive choice for API development. By leveraging the campaign strength of both these, we can see the backend operations can be executed faster with more reliability. The front-end developers gain the flexibility to query what they need without the connecting with the backend team. Like the schema is the contract between the front-end and the backend team. Overall, the system becomes more maintainable and scalable. Okay, so as we leave today, so I encourage you to consider trying GraphQL and the Fast API, and you can connect with us using this LinkedIn handle. And thank you for your attention. Thank you.